All right, welcome back. And let's do reflections. What we are going to deal with here is reflections over lines. And really, the overarching key to reflections is the line of reflection. And let me highlight that in orange. And so I've got a vertical line of reflection here for this first diagram. And then I've got a horizontal line of reflection here. And then I have a diagonal one. All right, so regardless of what we're doing, which direction we're reflecting, the key is that that orange line is the dividing line. If you fold the figure over the orange line, you're going to get the exact same figure on the other side. So all of the red, blue, and green dots all match up. Over here on this far figure, A will reflect down to A prime. B down to B prime, C down to C prime. And so a couple of things that I wanted to quickly review. If we go down here to the bottom, here's a couple of rules with reflections. And I'm going to circle this first bullet for you in blue. It says the point is on the line, then the image and the preimage are the same point. And that's this little diagram right here. All that's saying is the big orange line that I've highlighted up here, notice that all of the dots that we were reflecting were off the orange line. Well, there's going to be situations where the reflection, a point, is going to be on the line of reflection, so it doesn't move. That's just as easy as that. Don't move it. It's going to count as both the image and the preimage. Now, when we actually do the reflections, the point will reflect over the line of reflection, but the key is, I'm going to highlight this in yellow, and now this is not on your notes. It says it's the perpendicular bisector, so that means there has to be a right angle symbol. So that just means the line of reflection has to form a right angle with the segment connecting the image and the preimage. All right, so what we'll do is just apply this, and it's not really as bad as it seems. I know the definition's pretty bulky, but it's not as horrible as it seems here. And let's just prove this. On question number 1, it says you have triangle JKL, and I've already graphed it up there for you. And we're going to graph the triangle and its image over the line x equals -4. And so basically, in order to do reflection, I have to give you a line to reflect over. And here it is, x equals -4. That's this vertical line. And so what we're going to do is graph the image, and I'm going to color the image in blue. And so if we start with this top point J, and I didn't label it, so let me label that real fast. So this is J. And so if we count spaces, J is 4 units, 1, 2, 3, 4, 4 units to the right of the red line. That means it has to reflect 4 units to the left. All right, so if we reflect that 4 units to the left, we're going to get J prime, put a dot there, and you're done. And you're going to move on to the next point. And so I believe we have another point, -2, -1. That's K. If we reflect that, it's 2 units to the left of the red line. That means it'll reflect 2 units to the right. Excuse me, 2 units to the left. It's 2 units to the right. It'll reflect 2 to the left. And so there's K prime. And then we'll do the same thing with our L. Here's L. And it's going to be, this one's a little different though. It's 2 units to the left of the red line. It's going to reflect 2 units to the right. So L prime will be here. And all we're going to do is connect our dots and make sure we have those connected properly. And this will be the image of the reflection. Now, we're going to do the same thing on number 2. We're going to reflect this triangle up above. And so we're going to do this real fast. If you reflect this point here that is called L, is going to reflect 2 units above the red line. And so that's going to give me a point. Let me highlight that. 2 units above the red line here. And then K is 4 units below the red line. So 1, 2, 3, 4, it'll reflect 4 units above. And like on our notes, we have a point that's on the line of reflection, so that is not going to actually move. And so here is the image of my reflection. Now we're going to do the exact same thing on the next page. You're just going to count spaces, reflect over the y-axis, x-axis, in all of these equations. Now notice what I've got for you down here on the bottom. These are rules. Instead of having to plot the figure, count spaces, reflect it, and then find the new image, there are shortcuts. So notice it says for the y-axis, if I start with x comma y, instead of plotting and counting spaces, I could just change the sign of the x value and leave the y value the same. And you'll notice, and I'm going to highlight this for you in a different color, here are my original images, original pre-images. And notice that the image are these orange objects here. And so notice that they just changed sign from positive to negative or vice versa. And notice that the y values did not change at all. All right, so what I've got for you here are three extra rules that it would be a great idea to know these rules. This will save you time. If you know them, you can just apply them and be done with it. Now, the y equals x and the y equals negative x rules are a little tougher, and I'm going to quickly kind of go over those. Y equals x is this little diagonal line here. Y equals negative x is this diagonal line going the other way. And so those are the lines that we're reflecting over. And so if you take A and what you're going to have to do is use opposite reciprocal slopes. And so the slope of the green line, I'm going to write this out here, the slope of the green line is 1. And so that means any reflection has to have an opposite reciprocal slope. And so I'm going to draw a red line, kind of like this. This little red line has a slope of -1. So I'll put that right there. So slope equals -1. And so I know that my reflection of A has to be somewhere on this red line. And so like if I were to say, could it be way down here where my cursor is? It can't be because that's too far. It has to be the same distance from the green line. And so if we kind of estimate it and kind of eyeball it here, we can kind of see that this point right here, I'm going to darken this, that is going to be the location of A prime. And we'll see that that's at 2, -1. Well, 2, -1, if we go back to the original coordinate, all we did is we just switched the x and y's. And so the method that I showed you here with the green lines and the red lines and opposite reciprocal slopes, yeah, you could use that if you want to. It's a little bit unnecessary and it's a lot of work, quite honestly. So I would prefer you to know the rules. And so, but if you don't remember the rules, then you could use opposite reciprocal slopes and you could still be successful. All right, so that takes care of your rules. And on the next page, there are 3 examples. And take a moment, about 2 minutes or so, to take a look at those. And I'll post the answers here in a bit. Okay, on the next couple of pages, examples 3 and 4, I've got the images, the coordinates listed for you. I didn't draw the image on question number 3. But I do have the coordinates for you. So just make sure your coordinates in your graph, my coordinates in your graph match up. Got the coordinates for number 4 written out for you. And then for number 5, I know, first of all, I just fixed it here. This is y equals x. And so I know the x kind of got cut off there. But just apply the rule, and here are your answers there. And this is as far as A-Day got. There are a couple of examples on the next page, the miniature golf question and the driveway question, that we didn't get to that in A-Day, so we'll just pick up with that probably, well, when we get back, or when I get back, and we'll kind of clean that up. But that is everything that you need for reflections. And what I need you to do is use the videos, the translation and the reflection videos that I've given you, and use those to help you on your homework. And we'll see you all on Thursday. Have a good day, everyone.